paper, put a big X over that, and down here we're going to talk about the transformations. And then we'll do a couple of examples and y'all should be good. Alright, so when we talk about the transformations, first things first, I need y'all to remember the transformations for a quadratic function, okay? Because these, again, are inverses. They're related, so you actually find transformations the same way. So for a quadratic, remember it had to be in vertex form. Y'all are with me, right? Okay. If we remember a quadratic, I'm going to use pencil. The A value was a stretch or compression, right? If A was bigger than 1, it was a stretch. If A was a fraction between 0 and 1, remember that means we pressed it down. So that was a compression. And hopefully you guys remember that if A was negative, that means the parabola, why did I make a W? Lord Jesus. The parabola was flipped, okay? So negative equals reflect. And it was a vertical reflection. You don't do horizontal reflections until Math 3 and Pre-Cal, all right? All right, we should remember that the inside, the H, is the horizontal shift. And what you have to remember here is it's always the opposite, right? So if it says +3, that really means we moved to the left 3. And if it says -3, that means we moved to the right 3, okay? And last but not least, hopefully you remember that K is the vertical shift, the up and down, because it's outside with the Y, all right? So those were our quadratic transformations. Now I want you to check this out. Square root transformations are the exact same, okay? Except it's with a square root function. So our parent function, or our function that we're dealing with, is going to look like this. But doesn't that look very similar to this, except instead of squaring the inside, we're taking the square root because they're inverses. But what this means is all the transformations are found the exact same way, okay? So over here, just to get y'all ready for pre-cal, when you see this, you should know that HK is your initial point or your vertex. Just like up here, HK tells you the vertex. Down here, it tells you the initial point. So HK equals initial point. Okay? Same thing with the transformation, so I am going to write those down one more time. If A is bigger than 1, that means we stretched it. If it's a fraction between 0 and 1, like 1/2, 1/3, 1/4, 2/3, that means it's compressed. We're pressing that function down, okay? If A is negative, that means there was a vertical reflection. I am abbreviating down here. If H is negative, we really move it to the right. If H is positive, we really move it to the left. That's your horizontal shift. And remember, it does the opposite. And then K is your vertical shift. Okay? So once you have those down, you're good to go with examples. So I'm going to go ahead and keep going in the video so I can keep it as short as possible, and we will move on to examples. So you don't have this worksheet. I just want you to write these down somewhere because we're actually going to use Desmos to graph them once we state the transformations, okay? So I'm going to do number 1 and number, actually, yeah, I'm going to do number 1 and number 5, okay? So let's look at 1. On your homework it says state the transformations first. So I know this doesn't say state them, but I'm going to so you know how to do your homework, okay? So first, for number 1, my transformations are, it says +3, which really means we moved it left 3, right? So there's a horizontal shift left 3 and a vertical shift down 1. Now, those are the only 2 transformations I see for this one. So once you state your transformations, the next thing I want you to do, and again, it doesn't say it up here, but it does say it on your homework, is I want you to find the initial point. And there's a reason I'm doing these without graphing, because these should be quick. You need to know how to do this in Math 3 and Pre-Cal, okay? So the initial point, if I'm looking at this, if we went left 3, down 1, that means I'm starting at -3, -1. Does that make sense? Okay, so once you've done those 2 things, now you are good to go to Desmos, and we are going to type in the square root of x plus 3, and then I'm going to hit the over arrow so I'm outside of the radical -1, and I did forget to put my y equals. There we go. All right, so do you guys see how Desmos graphed it for us? So take a look at this initial point right here. The initial point is at -3, -1. I don't know why it's not popping up and staying. Okay. Now, the only other thing you have to do on this worksheet is find the domain and range, okay? So we're going to use our graph in Desmos to find that domain and find that range, all right? And I'm going to use these points that Desmos has in here, and I'm going to put them on my graph here. 1, 2, 3, down 1. Then it's at -2, 0. And then we've got a nice point right here at 1, 1. When you get to math, probably actually not in Math 3, when you get to Honors Pre-Cal, we will actually graph these by hand. I'll show you how to do that, okay? So, looking at this graph, the domain, the x value starts at -3, that's the x. So the domain starts at -3, and these are always going to the right. So it's going to go to positive infinity, okay? Now the range, the y value, the smallest one is down here. So the y value starts at -1, and this one is going up, it's increasing, okay? So it's going to go up till it hits positive infinity. All right, so that's how you do number 1. Let's move down to number 5. Get out of Desmos. Okay, so same thing here. I want you to do the transformations first and the initial point, then we'll go graphing in Desmos, okay? So the transformations for this one looks fun. We've got a negative outside, which means there was a vertical reflection. I'm just going to go in order, okay? So next we've got a 3 outside. 3 is bigger than 1. Remember, you don't worry about the negative. We already dealt with that. 3 is bigger than 1, so that means this is a vertical stretch by a factor of 3, right? And then, good news, there's no shifts inside with x. So there's no x shifts, no horizontal shifts, but there is a vertical shift of down 4. So now we just need to do our initial point, and then we are good to go graph in Desmos. So my initial point here, if there's no horizontal shifts, it's going to start at 0 still, because our parent function, remember, started at 0, 0, right? But then we shifted it down. So it starts at 0, but then it's down here 4. So that's 0, -4 for my initial point, okay? So once you have that initial point, you are good to go to Desmos and graph. So all we have inside is x. It's -3 square root of x minus 4. And I've got to move my graph this time so I can see what's going on. All right, so we should be able to see this one good. So check yourself. Let's check our work before we graph. The initial point is at 0, -4. That looks good. Now it wants to pop up. Y'all saw that. Okay. And then this one is going down instead of up. That makes sense because this one was vertically reflected. So instead of being here, we flipped it vertically and now it's pointing down. Okay. So that's not going to change my domain any, but it is going to affect my range. So let's talk about the domain and range for these two, okay? The domain, the x's start at 0, and then they keep going to the right, which means they go from 0 to positive infinity. All right, but the range for this one is at -4, but it's going down, which means it goes to negative infinity, right? Now, do not write -4, negative infinity. Remember, it's got to be in order from the smallest y to the biggest y. So the smallest y is going to be all the way down here. It's going to keep going, which means the smallest y is negative infinity. And the largest y value it hits is -4. Okay? Hopefully you feel okay with this. If not, please, please, please hop on Zoom with me. I feel like you guys should be good with this. So on your homework, make sure you're stating the transformations. It says graph using transformations, so I want you to state them. Then you're going to state the initial point. Let me click so y'all can see what I'm talking about. State the transformations, state the initial point, domain, and range. Okay? Bye, y'all.